Hello and welcome to today's webinar, How to Build a Lightning-Fast Multi-Petabyte Backup Repository. This special webinar event is brought to you in partnership with Quest and produced by Actual Tech Media. Thank you so much to our audience for joining us on today's event. We've got a great event lined up for you. This is a hot topic. I know so many companies out there are dealing with this challenge, with an ever-growing backup repository. It's becoming more and more of a critical problem, not only on how to store it and how to scale it, but also how to access it with some level of performance so that you can do mass recoveries, and also how to protect it. So we'll be talking about all these topics and more on the event today. Before we jump into it, just a few things that you should know about the webinar. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator for the event. I'll be introducing you to our expert presenter from Quest here in just a moment, but we do want this to be an educational event. Being a former IT manager myself, I know how tough it can be to get information to solve your technology challenges, and this is a big challenge to a lot of companies out there. These massively growing backup repositories. So we want to help you solve your problems around backup and recovery and disaster recovery. So use the questions box in your audience console. I know many of you have already found it. We welcome all your good morning and hello messages from across the United States and around the world. But we also want your technical challenges, and we'll be queuing up those questions for a Q&A session at the end of the presentation. We also have a couple of handouts in your audience console. I encourage you to check out. We've got the product page for NetVault Plus, where you can download a free trial to the solution that we'll be talking about today, and also a white paper on the same topic as the webinar that you can download. It's a PDF asset on how to build a lightning-fast multi-petabyte backup repository. So make sure that you download that white paper before the event is over, because it won't be as easily accessible after the event. And then finally, if you're watching this event live, we'll be announcing the winner of our Amazon $300 gift card at the end of the event. If you're watching on demand, of course, the drawing has already occurred. The prize terms can be found in the handouts tab. And with that, let me talk about, just for a moment, the state of backup and recovery at companies around the world. Let's do a little bit of stage setting here and just talk about the challenge. I mean, companies out there are demanding really an infinitely scalable backup repository. There are some organizations where keeping that backup data is a requirement, either legally or just internally, for auditors. And the expectation is that the backup data will be there forever in many cases. Or in many cases, due to requirements, there are very lengthy archival periods, that are required. And data is just growing, faster and faster with, larger scale video content, graphic data, files. These backup repositories just require, the requirement is that they are infinitely scalable. And that's a big problem. That's a big challenge for a lot of companies. They also need lightning fast backup and recovery. And recovery is expected to be almost immediate, at many companies, even with large data sets or during a mass restore event. And unfortunately, more and more companies are being forced to perform these sort of mass restore events when they're infected with ransomware. And, that's a big challenge. Certainly, most every backup product out there, let's hope, can restore, a single file or a database or a virtual machine. But what if you had to restore every single file, every single database, every single virtual machine as quickly as possible? Could your backup and recovery tool support that? Would it take weeks or months and perhaps, put your company out of business while you're waiting for those backup or those recoveries to take place? And then it needs to be fully redundant. Any solution that you choose should ensure that your data is rapidly recoverable, no matter the scale of the disaster. So you need to have that data, a couple of copies, perhaps on site, and then at least one copy off site, and then at least another copy completely offline, so it can't be infected with ransomware. And that way, if there's a fire, a flood, a hurricane, or a mass ransomware infection, that data can be recovered no matter what the challenge is. And then finally, highly secure. The backup repository must not be breached under any circumstances. We have seen in the news with these ransomware infections that in some cases, and unfortunately more and more, the backup repository is getting infected with ransomware. And at that point, your only hope is to pay the ransom to some criminals out there, and that's not something you want to put your job and your future and your company's future on. You don't want to place hope in that. You want to have faith in a backup solution that's tested and working and is highly secure, won't get infected, will allow for these kind of mass restores and this kind of infinite scalability that more and more companies need. And so that's the challenge that we're facing today as IT professionals. And we're looking for innovative solutions to help us accomplish this. I know many of us have aging legacy backup solutions. In many cases, we've inherited solutions or we've acquired multiple companies, and we have multiple backup and recovery solutions. So I'm excited to introduce you now to Mr. Adrian Moyer, technical strategist for the CTO office at Quest, to talk about the Quest data protection solution and how it can achieve this kind of infinite scalability and high performance and high security that we're talking about. Adrian, it's great to have you on the event. Take it away.
Thanks very much, David. It's great to be here. Thanks for a great intro. I'll dive straight in. I guess we'll start talking about some of the issues and problems that pop up. And I think the thing you kind of touched on there is that this at large scale things start to have a problem, right? I mean, when we talk about large scale these days, and a lot of the people on this call have probably heard this already before about the data growth that's happening, and we keep telling everybody this is kind of exponential, and I think probably everybody globally has been looking at so many graphs this year that are non-linear in a way. And here's another one. If you want to look at this from a point of view from where we used to be, if you think about, all those years ago, you bought memory for a PC that was a box. We were talking like $35 a megabyte back then. It was really expensive. And we thought, well, what's a gigabyte in terms of cost of memory and terabyte? And, then we get into disk sizes that forever seem to be increasing. And then if we look at the amount of data that there is out there now globally, you start to see this trend, this huge data growth trend, and it is very much non-linear. We're at 2020 now, so we're just under the 60 zettabytes worth of data. So if you think about having a petabyte of data, or an exabyte is 1,000 petabytes, and a zettabyte is 1,000 exabytes. So we're at 59 zettabytes globally now. By 2024, which doesn't seem that very far away now, we're looking at 150 zettabytes. It's a magnitude jump. So data is ever increasing. It's being put in different places as well, though. So the kind of traditional data center-based backup solution sets, the data sets that you're looking to protect, they're kind of changing. There's more, in the collaborative cloud technologies. Certainly this year, that's been a great trend that's taken off. A lot of people have actually pivoted their methods and methodologies of working into that kind of collaborative cloud space. So that's great, and you can still look after the data set. There's no reason why you shouldn't be able to go and do that. But it's still going to grow. It's just growing in a different place. So you still have to be able to take care of that and actually store the data, as David was saying, and get that data back as quickly as possible. So let's think about that kind of storing the data challenge. When you look at large sets of data and how we want to keep them, because we've kind of grown over the years, we used to send a lot of data off to tape, and we said, okay, tape's great. It's to a point. It gives you that kind of air gap stuff. If you want to use that, that's fine. But the speed of recovery is probably not what people are after now. As human beings, we're relatively impatient things, and we want to have things working as quickly as possible. So, of course, if you've got large amounts of data then in your backup, and you start to think about, okay, what's a quicker mechanism? Well, we all look to disk straight away and think, well, there's a better way of doing things for things, making things go faster. But of course, then we get into the whole point of starting chewing up large amounts of data, storing data. and the data is essentially the same each time. Maybe you're doing weekly full backups. It's almost the same content every single week. So of course, at that point, people start to scratch their heads, and we get into the point of, the necessity becomes the mother of invention, and we start thinking about technology and how we're going to achieve better results. And of course, through that, we actually then start to see new technologies that arrived on the marketplace to meet these challenges. And one of those was deduplication. And deduplication comes in many forms. There are kind of many types out there as well. So um, there's always lots of questions around this kind of technology. So I thought I kind of go back to like the 101 on deduplication and look at it from that aspect. If I take a set of data, for example, that I want to go and store, maybe I'll take a first full backup of data. And within that data set, I've got data that is, will match. I have to store quite a bit of it, but the orange indicator here says I've already got one item called A. We'll call it a chunk, for example, as to trying to avoid other names. I've already got A stored, so I'll put an A pointer in and not store that a second time. So now I've started to think, okay, I'm saving some disk space here. And in a kind of general methodology, we start to see incrementals being done, and we see data being pulled through. There's some similar data there, so we'll put some pointers in and only store the unique data. And this is the key bit here, is that the level of repetitive data sets, the more of those we have, the more efficient our deduplication mechanism becomes. Now, lots of people say to me, how do you achieve deduplication ratios, and how do you go about that? And it kind of boils down to kind of a few things, really. One of them is repetitive types of data sets, as we can show here. The more times that you store those repetitive data sets, the better your ratio gets. And if you store them and keep them for longer, you have more data to match with new incoming data, then you'll get even more matches and the ratio increases. And here we can see this kind of in action. When you get to that second full backup, you get to that point of having another large set of data coming in that is very, very similar. In this little example here, I've only ended up storing or using space for that object J, that chunk of data J. The rest of it I've already got. I put some pointers in. I saved quite a bit of disk space. So this now gives me a mechanism here to actually store data. Now, I think there were a couple of questions on this, David, that popped up. The types of deduplication sets that were there.
Yeah, absolutely. I mean, we do have some questions coming in from the audience already, and we appreciate those. So when it comes to deduplication, I know there's a couple different forms, and they're asking, what form of deduplication exactly you're talking about here.
So this particular one is kind of generic to the point of actually just matching data blocks, but there are several types out there. So you've got things like fixed block, and you've got variable block. The variable block normally gives you a better outcome, but it's at the expense of a little bit more compute cycle. Fixed block will use more disk space, but can be less intensive. However, the intensity and the compute requirements, we've kind of got over that these days. So most of them out there are variable. We also kind of get into, what about source side deduplication? How does that work? And global deduplication. We'll touch on the global deduplication bit shortly. But the source side deduplication is kind of an interesting one, because you have this ability now to match data when it arrives at your disks. What if you could match the data before it actually goes across the wire? And that's the key thing here, is that we're now thinking about source side deduplication, is offloading that ability to have to wait for the data to arrive somewhere. So if we can actually do this on the fly, as it were, as data streams and data is processed and it streams out of the client machine heading towards your storage, if we can intercept that stream and say, I've already got that block or that chunk stored, I don't need to send it, it has a couple of effects. One is it reduces the amount of data traffic going across the networks, fairly obvious one. The one that's probably not so obvious is that if you think about what you've just done about not sending data to the target device, the interface on that target device now it's no longer saturated. So you can start thinking about, well, okay, I'll run another backup at the same time, and again, it's checking data already stored, doesn't send much over the wire. That interface is still not full. So you can keep running more backups in the same period of time. So the effective impact of things like source-side deduplication is it increases your throughput, your ability to process more data and get your backups done in a shorter period of time. So, and that just comes from offloading where the data matching happens. So there's that element that we can talk about too as well.
Yeah, very interesting. I mean, deduplication is a lot more than just a checkbox. Like, okay, yeah, we got deduplication. There's a lot
Yeah.
more to it than that. So thank you for explaining that. And then here's another question before we move on. I'm sure you've heard this one before. I mean, what kind of deduplication rates do you typically see?
Well, that's one of those questions like how long is a piece of string? As I said, a little bit earlier, that the more data you keep, the more matches you can make, the better that those saving rates you're going to get. That ratio gets better. So you'll see numbers thrown around out there. Realistically, out there over the years that I've been working with this kind of technology, 20-1 is pretty good. Is a reasonable standpoint that you want to aim for. That's around about a 93% saving over 12 weeks worth of data set. So you kind of have to think of it more broadly than just a ratio. It's a sets of data over a period of time that's going to deliver that for you. I've seen it as high as 93-1, and I've seen it as low as 2-1. Because in all of that as well, you have to think about the data itself. If the data doesn't match, then you're not going to get good deduplication ratios. If the data matches really well, then it could be better than what you'd expect. So things like virtual machines with the same operating systems in, they work really well in deduplication solutions. Images that are opened and rewritten each time, even though it looks the same picture, the data stream is different, and therefore it's unlikely to deduplicate as well as you would expect things like virtual machines. So there's a little bit of variance that you have to kind of consider.
Excellent. Okay. Thanks for explaining that.
All right, no problem. Right. So let's take these kind of concepts and then let's start thinking about making it a little bit bigger. Let's have a think about, now we've got all this kind of data set and we've got this technology that we can go and use in various forms. So how do we scale this kind of technology out? And what are the implications of doing this as well? So it's always one thing to think about going big, but do I really need to go big in a certain direction? Now, obviously, there's the simple way with storage. You can scale up and you can just bolt tons of storage onto there, but eventually it becomes a little bit inefficient with the amount of things it's got to do. So then at that point, we all start thinking, oh, okay, how do I scale out? How do I make this, super big? How do I get petabytes of data stored into something easily? And that's the key thing here. There's a few things to think about when you're getting into this kind of large scale storage. You've got there's kind of a balance you've got to take around how you're going to get the data there, what kind of risks are associated with a scale out solution, and how easy is that going to be to manage. So, and this is kind of where you have to think a little bit more than just throwing some storage at it and hoping that the problem's going to go away, because sometimes it really kind of doesn't. And you kind of have to think, well, okay, I've just done something, but it's inherently risky what I've just deployed. And I've done a few like that and thought, maybe I'll come back and do that a different way. So let's have a look at a few things there. There's a few types that are available out there at the moment, a few methodologies. So things like load balancing, global deduplication. Now, this isn't just about global deduplication across backup data sets. This is global deduplication across multiple devices. It's a whole different ballgame. And then there's this one called data-determined deduplication. And then just to add some little bit of spice into this as well, we'll talk about synthetic backups, something that's really kind of plagued deduplication solutions for a little while, about how that's achieved without stressing the storage solution too much. So let's hop into these and start with the first one. We'll start with the load balanced solution. So if I have a backup technology set and I create myself a device target group with all of these underlying deduplication targets sat there in a big pool, the idea is that for ease of management, I send my backups to this pool, and there's a level of intelligence in there that says, send this data to the least busy device, which kind of sounds, a good idea. It's going to help you get the backup done. It's the least busy one. So in that scenario, our data is going to come through and it gets stored, in this case, the one that's running the least busy at the moment at 10%. It stores the data set there, does any kind of deduplication with any other data set that's already there, and that's fine. However, when we come to do the same backup set again, so think about that second full backup. Think about having that data set that's nearly the same again. If I then bring that down and at the point of backup, another device is the least busy one in our load balance solution set, it stores the data over there. Well, okay, it's easy, it's straightforward, and I manage that. However, it's not an efficient use of the storage. I've effectively stored the same data twice. And the whole idea of deduplication is to try and avoid doing that, to reduce your storage footprint. What about the risk element here? Well, okay, let's think about the risk piece to this. What happens if, I've got another backup, it's different data. Now, with our load balance solution, I've got some data in green here on the right-hand side. So what happens now if I do an incremental and our least busy machine happens to be another one? So my backup chain now is on disparate systems. And I think you can probably work out what's going to happen here is that if I lose one of these systems that has data associated across the backup chain, and I wanted to get to that point in time, well, that won't be available anymore. It's going to go away. So your data availability is now beholden to potentially one system with a group of systems that you have no control over, because you have no control where the data goes to. And if that whole thing disappears, well, then we lose access to being able to recover that data. That's not a good conversation to have at that point when somebody says, I need the data back. So, yeah, we lost one of our machines in our pool, but effectively, unfortunately, all of the data points associated with those backups over the past many weeks, it's all gone. So load balancing, it's a relatively good idea. It's a good approach to a point. It's good for management. It's not so hot on storing data, and there's a little bit of risk associated with it too. And there's always going to be some risk in these solutions. However, you can see the impact of this. So let's move on to our next piece. Let's move on to our next kind of methodology, the global deduplication piece. Now, this is a change in methodology where the deduplication is not done on a per target basis. It's done across all of the targets. So there is a namespace that would be effectively across all of these devices, saying with a map of what chunks are stored where and where I can store the next chunks. And as you can see, I've got my data set here. It's spread across all of those now, and it's not on a single piece. Now, obviously, you can understand here that if I want to have this to be secure, if I lost one of my devices, I would lose everything because it's global across everything. So the way it gets around this, those unique blocks, the likelihood is it's going to replicate them. In this case, we've done a shift one to the right and replicated those chunks of data and stored them on the other devices. So now I've got 2 copies of those just in case one of my devices fails. Okay, you've mitigated the risk, but now we've got the scratching our head a little bit again around the storage usage. I'm now storing this unique data at least twice. And there are some solutions that do it as a tertiary piece too. So you're getting into the point here of it consumes more storage while you think it's spread out and I can get throughput and it's fast and effective. It's great. However, it's not so good on storage. And of course, when we look at the risk piece, this gets kind of interesting at this point. So if we think about losing one of these devices, and if one of them drops out the way, I'm going to lose those chunks of data as well. But that's okay. We've got another copy of those unique chunks of data. That's not so bad. It's not as bad as last time. So what I can do now, if I'm a self-healing solution set, which that's not beyond the reasonable bounds of these days that we can achieve that, what's it going to do? It's going to look at what those single blocks are that are left, and it's going to replicate them. And in this case, it's a shift one to the right. Okay, I've kind of self-healed. I've got my 2 copies of my unique blocks back again. I've reduced my risk. That's great. However, I've impacted my storage even further now because some of those devices are now more loaded than others. So if you're tight on space and you lose a device, you may start to have issues around only having single unique amounts of data. So to get around this, they usually over-provision the amount of storage and reserve it so you can't use it. So you've now got storage that you can't actually use because the solution is a bit more risk averse, and you're storing the data twice. So something to think about there. So that's the kind of the global piece. So let's go and think about a little bit more about being data determined. And let's think about what this really means. If I look at this from a point of view of still having my devices and still having a device target pool, and then think about, here's my data sets. I've got different backups stored on those data sets. Now, what does data device target mean? What does it mean to be determined by the data? Well, what actually happens here is that my data sets that are coming in, instead of choosing which is the least busy or spraying it across all of the devices, the intelligence is usually provided by the backup solution to say this data set from these sets of machines, because it could be multiple machines, it doesn't really matter, they were last sent to this particular device. So in this case now, instead of me actually having to put it on another randomly chosen box, it's now going to where the data was last previously stored associated with those machines that are backing up. And of course, because we've done that, we're going to get the best use of our data set. It's going to deduplicate really well because it's the same data source as previously. And we've kind of solved the whole storage element in terms of getting the best usage out of the storage. Manageability is pretty good as well, because if it's done right, it's done intelligently, such that you don't have to worry about it. It's going to go and deliver that for you. So what about the risk element? So the risk element to this, if I then lose one of these devices, it dropped out the way, and I've got my data set disappears. Because the data sets were tied to and known from those sources, one thing is you're going to know that which ones are affected. That's one extra element that you're actually going to have a bit more knowledge. And the other one is that it's only those backups from those particular machines that are affected. And if you were doing incrementals to the same space, to the same device, it's only those that are affected. Anything else across my device sets, because I've put them all in their unique places where they live dependent on the data sets, they're not impacted at all. And I don't have to replicate extra copies around through this solution either. Now, you can choose to do that, as David was saying earlier, having a secondary copy somewhere is very good, so you can replicate the data off and have that somewhere else. And or a lot of people these days take the data, aged out data, and tear it out to cloud storage. So there are other ways and other mechanisms to give you alternate copies somewhere else and give you that 3-2-1 rule, plus also securing it offsite somewhere. So being intelligent about how we store the data is possibly better than just throwing it at a set of devices and letting the devices work it out. Actually have the intelligence in the software to say, do you know what, there's a better way of doing this. And that data determined methodology is possibly the best balanced methodology out of all of them to actually deliver you the usage of storage, mitigate the risk, and provide you with a level of intelligence and manageability that's very, very easy. It's still a pool of targets. You just let the software decide where it's going to go put that data set. So, of course, where does this drive us to? Well, it drives us to, obviously, a solution, a Quest that we can provide to help with this kind of technology. And that solution we have is called NetVault Plus. Now, NetVault Plus is a technology solution of two particular products that are tightly integrated together. One is NetVault Backup. The other one is a software-defined storage solution called CoreStore. Now, CoreStore is a software technology that can be installed on your own hardware, in a virtual machine. You can run it in cloud. You can even use object cloud storage as a back end if you so wish to reduce cloud costs. It's not defined to be on a particular piece of hardware either. So if you really want to scale out with hardware, you can use whatever hardware you like from your favorite supplier. It's kind of up to you. And how does that work with our data determined piece? Well, if I look at my protected resources here now, I can look at these in a different way. I can look at these machines that actually then send their data out in particular methods. So if I had a bunch of machines that push themselves out, as we'll call them, this is the yellow set. I mean, this could be multiple machines or multiple VMs, particular backup jobs. You kind of take your choice at that point. I have another set that are green and another set that are blue. And the nice thing that we do here with NetVault, it looks at the data sets and looks at the available resources that are inside that pool of storage with the core store devices. And then it determines where it's going to go. And it will always send the backups from the yellow machines to one instance, the green machines to the center instance, and the blue machines to the final one. Now you're probably all thinking, oh, how does this work with deduplication? How is that, isn't that, per job deduplication? Well, kind of yes and no. So you notice here I've used multiple sources for my data sets. They will all go to a core store instance and they will all be deduplicated against each other. Any landed data in core store can be deduplicated against any other landed data. Now core store is pretty agnostic. It actually supports 13 different backup solutions. It works, very, very well with our own technology because we have integrated it pretty tightly. However, it would even deduplicate data from NetVault along with data from another product as well. So it becomes global within its instance of where you're sending the data to. And if you've got multiple instances, you've now got related data sets that are known to be good, known to match very well to give you the best kind of storage outcome. So this is all, this works very, very well. It covers all the things we've been talking about. But I'm going to add an extra little bit in there. At the bottom of that list we started with was synthetic backup. Now I think David, you wanted a question about synthetic backup.
Yeah, there was. We've all heard of archivals and incrementals when it comes to backups, but can you explain to us exactly what a synthetic backup is?
Sure. So, and I use this as an example. So, a synthetic backup, the idea of this is to try and remove you having to do regular full backups and pulling all the data from all your systems every week. Essentially, that's the first piece. The second piece is that people will say, oh, well, we can do incremental forever. Okay, that's fine. You try and do incremental forever for a couple of years, and then you come to restore it. And one of those bits in that chain that you've had for 2 years, if it doesn't work, you're not going to get things back. So the way around this is that you say, okay, well, the way around it is to create a new full backup of everything and then start your incrementals again. But that means I've got to pull all my data again. Don't like doing that, really. So we try and do that synthetically. Now, there's a method around this, the way that we do this. And I use this as an example in our slides to step through this. And my mouse has disappeared. There we go. Right, so our first thing is to think about using the data sets. So we create a full data set. Now, we use something called RDA, which is our in-house rapid data access protocol. It's a non-published protocol. It's not like NFS or SMB. It's closed. It provides source-side deduplication as well. And we create a full backup, which is fine. And then during the week, I'm going to want to go and create some incremental backups that are associated with that full backup. That's great. Now, you get to that point of thinking, okay, I need to have that new recovery point in time to start with my full backup again, but I don't want to do that. So the idea here of synthetics is to try and read the full backup and all the previous incrementals and create from that set of data a new point in time, which would be classed as the next full backup. And it's generated from the data we already have stored, hence the term synthetic. It doesn't really come from the machines that we have, it's just the data that we've already got. And we create a new recovery point, and then we go and start pulling incremental data again, and then we repeat that synthetic process. So does that explain the synthetic piece for you?
Absolutely, yeah. Very smart.
Okay, yeah, it's a smart way of doing things. Now, if you think about stepping back a little bit to all those different types of storage pools that we had with global deduplication and load balance, and you think about those two specifically, that data is spread across all those devices. When you come to create that synthetic full, traditionally, backup solutions used to have to read the data out and then rewrite it again. And if you can imagine doing that across all of those devices and all that data flow, and then where am I going to write it again? The load balance says, oh, this one over here is the freest. I'm going to stick it somewhere over there. The global dedupe one is going to be lots of blocks flying around and storing lots of blocks all over the place. And you still have to pull data in and out. Now, the difficulty with that is, with any kind of deduplication solution, if you're reading data out of it to rewrite it, it's going to re-inflate it again, and that puts a strain on the storage and slows everything down. So the solution we have with NetVault and CoreStore, and this is why they're so closely tied together in terms of being integrated, is that NetVault will say, I need to have a synthetic backup done at my new point in time. And it will then use RDA, and it will go and talk to CoreStore and say, tell me the full backup maps and the incremental maps. And it says, okay, I've got all of those now. I want you to go and create me from those data sets a new synthetic full. And we issue that technology into the storage layer inside CoreStore, and it goes and creates it locally within the storage piece. Now, if you consider doing this with our data determined methodology in our storage pool, because those machines and those backup jobs that you have that you've asked a synthetic full to be done, because the data is on the same location, the synthetic full is done within the same storage construct on the same node in our pool and is very, very quick. We're only going to generate new pointers here. So it's super fast. We don't have to go and reference across a ton of other devices within our pool anymore. So it's super quick. So you get benefits around not dragging the data. You get benefits around doing it very, very quickly. And you still get benefits around of storing the data. Well, it's just a bunch of pointers, so you're not actually going to store any more data. So it still becomes easy to do. So hopefully that gives you an idea of having synthetic fulls done at a storage layer and the advantages of doing it there as associated with the traditional methodologies of people pulling data back out with their backup application and writing it back in again. Now, I see we're getting quite a few questions on this now. So do you want to run through some of these questions, David, we're getting here?
Yeah, absolutely. So let's see. First one here, I see, how does the data from the protected resource get into the CoreStore pool? Does this use agents, or how is that transferred?
Okay, so NetVault has can do things with agents, and it can do things agentlessly as well. So if you're in the virtual world, if you're using VMware or Hyper-V or Nutanix, for example, or even Red Hat, then we can do that from an agentlessly piece. Now, what's kind of nice is that the way that NetVault is built, it's very modular. So for VMware, for example, let's use that as an example. You can run a little virtual machine as a proxy server. It could be Linux or Windows, and you install the NetVault software there. It will go and snapshot the machines for you, and the data flow comes out either hot add or fiber channel connect, or however you're doing that piece, the back end. As soon as it comes out through the NetVault piece there, it doesn't go through a media server. It will go directly to CoreStore. So we're going from client to storage direct. And we get source-side deduplication at that point as well. So if you think about scaling that out in VMware, you could go and deploy one of these small proxies, one per host, for example. And NetVault will look at that and find the most applicable proxy to use, determined on where the virtual machine is currently residing and which host to bring that out from, and then send it directly to the storage. So it reduces the number of hops. We get source-side deduplication, so it's nice and fast, and it's very, very scalable. So you have scalable at the front end as well as scalable at the back end. With agents, if you've got physical machines, sure, we can deal with that. Windows and Linux and HPUX and AIX, Solaris, all the usual kind of stuff. And again, you still get the source-side deduplication technology through that too, and it still goes straight into CoreStore.
Excellent. Yeah, a lot of flexibility there. Very nice. Let's see, if you have a question out there in the audience, now's the time to get it in. We got lots of good questions coming in, but if you have a question that's in your head, go ahead and just post it there in the questions box. Next question, what about recovery options, Adrian? What kind of recovery options do I have? Block-based, file-based? How does that work?
I could say both. Depends on the data sets that you protected. So for example, virtual machines, we back those up in a kind of a block methodology. We can put the virtual machine back to a point in time, or you can recover files from within it. So you kind of get both options in that scenario. If you've backed up a physical machine, we can recover a bare metal piece from the OS or individual files. Then we have technology plugins for the databases too. So SQL, MySQL, Postgre, DB2, Oracle. And you're then into the database restoration technologies as well. So Office 365, emails, OneDrive, files and folders, and the SharePoint piece, and Teams as well, we've just added. So there's lots of ways. So depending on the kind of technology that you're protecting, we will put it back in the most appropriate fashion.
Got it. So this is application aware you're talking about?
Absolutely. So even with those virtual instances, it can be application aware. If you're running SQL in there, we'll go and call VSS through the VMware tools and quiesce the database, snapshot the whole machine. If you want to go a little bit more granular with things like SQL and Oracle, for example, Oracle, we interface with RMAN. SQL, we can either use VSS or VDI and be really kind of granular about what you want to do. And again, fully application aware.
Nice. And then there's another question here about disaster recovery and getting data offsite. If the primary data center's, let's say, destroyed, what options did I have to get that data offsite and recover?
Well, it's actually pretty nice, actually. I mean, if you think about the replication options that people look for these days, with NetVault, we can actually run that as part of the solution. And we can call CoreStore to go and replicate the data sets somewhere else. And when we do that, we actually hand off that whole thing to CoreStore. So it goes from storage to storage. Again, there's no media agents involved here. So you can have all your data sets available somewhere else. You can even put these data sets up into cloud if you so wish.
Nice. So I could recover this data in the cloud or to an alternate data center.
Data center, colo, yep.
Yeah. Excellent. And then there's another question. So the architecture for CoreStore, where does this actually run? Is this running on premises? Is this running in the cloud?
It's one of these things where it's really quite nice to say yes, any of the above. You can run it on premises on hardware. You can run it on premises in a virtual machine. You can run it on premises, in cloud on a virtual machine as well. And one of the changes that we've just made with our recent release around this solution, the storage element, if you're running in cloud, if you wanted to have, a couple of 100 terabytes of storage or managed disk on a virtual machine in cloud, it's not the cheapest, should we say. So what we've actually done with our latest release, instead of you running managed disks for the repository for CoreStore, you can now use object storage. So the data comes into CoreStore, gets deduplicated, compressed, encrypted, and then gets stored out in Azure Blob or AWS S3, which is on average 8 times cheaper than spinning disk or managed disk. So you've got a cheaper alternative, but still deliver the same kind of technology set in cloud as well.
Nice. Very nice. And then, we talked about getting data offsite, but kind of what's your recommendation around having multiple copies of the data? For example, how many on-site, how many offsite? Do you take data offline so that it can't be, modified in some way? What's your recommendation there?
There's lots of recommendations. I would always recommend having more than one copy. That's for sure. We've all become risk averse in our old age. I think, and backup is no different. Having a local copy to do quick recoveries from, very important. Replicated copy somewhere else. If your main repository goes down, you can still get your data back. Longer term storage, you start thinking about, okay, well, longer term storage, I'm getting to taking it off site at that point. Now you kind of get into the whole question around tape or no tape. Do I do tape? Do I do cloud? Do I cloud? Do I not do tape? It's at this point, it gets to the point of me saying, use whatever works for you. Right? There are many ways of doing this one, and NetVault will do all of those ways too. So if you want to move data out in cloud and abstract it away from production, then do so. If you want to write it from your disk solutions, your secondary copy, and write it out to tape as a third copy and have it taken off site somewhere, fine, do that. All I will recommend is that have a copy that's not on your main site somewhere at a minimum. And if you really want to have belt and braces, then have a tertiary copy on an alternate solution set, either in cloud or you write it out to somewhere else that looks after that kind of solution, whether it's disk, whether it's tape.
Solid advice. And then, I hate to say the R word, ransomware, but can the backup repository become infected with ransomware?
Hmm. That's a really good question, and it is a question that crops up an awful lot these days because ransomware's evolved, right? I mean, it used to be kind of spray out there. It's becoming a bit more targeted, and it's beginning to understand that the way that some products store their backup solution sets and the file types they use. They go after those file types straight away, and it's a really kind of hard thing to think about. You think I've got to back up everything, it's fine. And we're obviously with ransomware, from my perspective, there's an education piece that where it comes in at, the user space. You don't click on links, you don't go to sites that looks interesting. So the introduction of it is a whole nother story. But here's the interesting thing with NetVault Plus. Using NetVault and utilizing CoreStore has a few distinct advantages. And the first one is that you can reduce the threat vector. A lot of ransomware targets the Microsoft base. NetVault can run on Windows. It can also fully run on Linux too. CoreStore is also on Linux, and it can be run and installed with just a minimal install. And in fact, when you actually install CoreStore, it will even say, do you want me to set up the firewalls for you? So it will do all that for you too. When you connect NetVault with CoreStore, it uses a username and password that is not part of any other username and password construct. And this is where it gets kind of interesting. When you look at the attack vectors that are associated these days, one of the first things they go after is Active Directory. And you start getting into GPO exploits. And if they get into that piece, then it does become very, very difficult. I mean, Quest also has solutions to help you with that scenario too. However, if you think about one of the things that people like to do with all of their systems and tag them into Active Directory to make it easy for themselves to actually use and authenticate against. Now, you can do that with NetVault. It supports the use of Active Directory, Azure AD, and LDAP. But if those become compromised, you run the risk of actually opening the door to somebody being able to go and use your backup solution in the way it was intended to go and delete your data. So that's one of the other things that you have to think about. It's not just about getting to the data itself, the usability of the application. Now, NetVault can use those authentication constructs. However, it can also have its own authentication construct with role-based access. So you have the ability to have it near enough to your production solutions to get the data, but disassociated far enough away from them to prevent actually intrusion from anything else. And that's the important piece as well. Alongside with RDA as well, because it's a non-published protocol, it's not an open protocol like NFS or SMB. There are no shares for it to actually go and broadcast. So there's very little access into that element too. And then the data we store, because it's deduplicated in the way it's written, it doesn't associate itself with any of the original files or file types. It's just literally a data points and a block map. So again, it's almost impossible to understand. If you add encryption on top of that, then even if you walked into the data center and just pulled it all out, you're going to have a hard time just trying to sift through and work out what was on there. So it's pretty secure in that aspect with the R word, should we say.
Nice, nice. And then, I talked about at the start of the event here, the need perhaps to perform a mass restore
Yeah.
and how many solutions out there, struggle with that. What could we do around a mass restore with CoreStore?
If you think about that in terms of pulling that data back, there are a couple of things that you can do with CoreStore. Because you can choose your own hardware if you want to put it on hardware or virtual machines. You can choose if you want to have faster disks. Things will run faster. CoreStore also has something there called the performance tier, where if you have a bunch of those highly sensitive systems that you want to have back super quick, you can actually store them within what we call the performance tier inside CoreStore. Now, well, it's performance tier. It's effectively just a file system mount point because of the nature of CoreStore and its ability to be agnostic to hardware. You can put in some solid state disks with a different mount point and introduce those as the performance tier. It's even has an optimized algorithm that runs around that performance tier as well, with a level of caching inside the way that we work that. You still get deduplication, you still get compression, but with those algorithms and the faster disk, we can actually do things like instant boot technologies derived directly out of core store without you having to sacrifice the need of actually having things like landing spaces where you don't touch it for a week, or you can still deduplicate, you can still make the best use of your storage, but not have to compromise on recovery speed. So there's a few things we can do around there. Now, if you want to do that on the mass thing, then obviously having more of those nodes within your intelligent storage pool, and you start pulling data from each one of them, think about where you're pulling it from, and then you'll be able to stream back those multiple pieces directly. And NetVault's recovery mechanism is the same as its backup mechanism. It goes directly from the storage to directly where you're restoring the data to. So virtual machines, for example, it would go back through those proxy servers and then back into the host-based storage that you were looking at. So again, you can kind of scale the recovery procedure as much as you were scaling the backup procedure.
Very nice. Yeah, that's so critical these days, being able to perform that kind of mass recovery should the need arise. Let's see, Adrian, there's a lot of good questions coming in the folder there. If you want to, if any of those catch your eye. Another question I had for you is, we have the link on the screen to NetVault Plus. There's a question here where they're asking, what's the difference between just NetVault and NetVault Plus?
So the difference between NetVault and NetVault Plus is core store, and it's a way of actually getting hold of the technology. So NetVault Plus is an enabler for you to buy the complete solution, NetVault and core store together. It's a very, very simple purchase buy at that point. The technology themselves are separate. However, they do integrate really, really well, to a point where that once you've added core store into NetVault, you can actually do everything you need from the NetVault user interface. You don't have to hop out to the core store interface to go and add extra storage targets and everything else. So it's a really tight integration at that point. But the difference being is that if you want NetVault as a backup solution, you want to go and use different storage, then it's just NetVault. If you want to have the advanced technologies and capabilities that we've talked about today, then NetVault Plus is the way to go.
Excellent. Okay.
I've got there's a question in here. There's one that's pulled in there. I think it's from Ken.
Yeah, I see that one. Ken's asking, what about the impact on rehydration rates when it comes to deduplication?
So that's a good question. There is a limit to which you can get to. So obviously, if you deduplicate and compress, too aggressively, it does impact the rehydration point. So we take a balance on that, and we have some algorithms that help us align where we store things to the data streams that actually enable us to actually have the rehydration piece. What's kind of interesting for me is the cloud tier technology inside a core store. Even though we've already deduplicated the data once and compressed it, we actually can do that even further with the data we send out to cloud, because its recovery time isn't required to be as quick. We can actually get even better savings before we send it out. So we kind of take a balance on the speed of recovery and the level of storage that you're going to get in terms of usage. So it is a bit of a balance, but it's one that we do take. So it allows us to actually see that. Hopefully that.
And then there's a question from. I'm sorry, Adrian. What?
That's all right. Hopefully that answers Ken's question.
Yeah, great answer. There's a question here from Blanca. She's asking, does this technology work for any platform such as Unix, Linux, Windows?
Yes. So NetVault will support all the Windows variants up to 2019. We have support for, I think it's 12 distributions of Linux, something like that. But all the obvious ones are there. Red Hat, CentOS, Ubuntu, Oracle Enterprise Linux, all the ones you'd expect. And then we have Solaris and HPUX and AIX, so the Unix piece is there too. And the source ID deduplication works from all of those platforms. So if you're running things like Oracle on AIX, for example, then you will still get source ID duplication through the RMAN technology in NetVault and out to core store. So yes, it's across all those platforms. The Backup server itself, you can install on either Windows or Linux, and then the clients, you have all of that wide breadth of coverage.
Excellent. Excellent. Next question I see here from Vanata. Sorry if I'm mispronouncing it. Vastana. There we go. She's asking if there's a demo version that we can download.
Yeah, absolutely. You can download demos of both NetVault and CoreStore. In fact, we actually have a community edition of CoreStore that includes a terabyte free forever. You can go and stick it in a virtual machine somewhere and go and play to your heart's content. But yes, trials for both parts of the technology are available. You can download them and go and play, fully featured, fully functional.
Excellent. And I just replied to that question with a link to go to the NetVault Plus product page. That link is actually already there in the handouts tab. You can go there and click on free trials and download NetVault Plus, as well as all the other Quest products as well, it looks like. So let's see. I know we're running short on time here. If we go through the free trial, any tips or explanation on kind of how that works, time frame, what to test? What do you recommend?
Easy one to test, I guess. VMware is fairly easy. Download NetVault, download the VMware plugin. You can install the plugin on the NetVault server if you so wish for a trial. Put in the credentials of the virtual center server. It will go and discover everything there for you. Add your CoreStore instance into NetVault, and then go and start protecting some virtual machines. It's that kind of simple. Everything is a web-based UI in there as well, so it's very easy to get around. And of course, if you need any help, then you can always reach out to the guys at Quest. We're always more than happy to help with that kind of stuff.
Awesome. So it's quest.com/netvault plus. That'll take everyone there for the free trial. We're running out of time here in our webinar slot. Before we go, I do want to announce the winner of our Amazon $300 gift card. That's going to Scott Force from North Carolina. Congratulations, Scott Force from North Carolina. And before we wrap up, I want to also remind everyone to check out the white paper that's available for download there in your audience console on the topic of today's webinar, how to build a lightning-fast multi-petabyte backup repository. Well, Adrian, I learned a lot on the event today. I know that the audience did as well. Thank you so much for your excellent presentation.
Thank you very much for inviting me along, David. It's been an absolute pleasure.
Excellent. And thank you to our audience for joining us on the event today. I hope that you have a great weekend. And after this event, you'll be redirected to our events homepage. And we look forward to having you on another upcoming event. And don't forget to visit quest.com/netvault plus and download the free trial of CoreStore and the NetVault solution. Have a great day. Bye-bye.